Hi there, welcome back to this channel. In this video, we're going to be talking about the phase difference. And we're going to be doing some calculations. You're going to see the possible questions that you may be asked in phase difference. So, but first, what is phase difference? When you say 2 points on a wave, on a progressive wave, when you say 2 points on a progressive wave are in phase or out of phase, so 2 points are either in phase. We talked about that in the last video, and we said they are out, or we say they are out of phase. So 2 points can either be in phase or out of phase. Now look at our progressive wave here. Now if I pick these 2 points, for example, if I pick these 2 points, this point and this point. Now looking at them, they are not in phase. Why? Because they do not have the same distance from this point of displacement, and they are not in the same point on the graph itself. You look at it well. But this point is only in phase with this point. Is that okay? No? This point is in fact not in phase with this point. This point is actually in phase with this point here. Do you get it? This point is in phase with this point. This point is in phase with this point. This point will be in phase with this point, not with this point. Do you understand? All right. So 2 points are in phase if they have exactly the same. First, they have the same frequency at a particular time, the same amplitude at that particular instance, the same um, um, displacement away from the horizontal. So that is when they are in phase. Now, but what are the possible questions we could be asked in phase difference? First, the phase difference, the sign for that we use to denote phase difference is this. It's called phi, which is a Greek alphabet. Okay, so phi represents or denotes phase difference. Now let's calculate phase difference. How do we go about it? First, remember that the formula for calculating phase difference is 2 pi x over lambda. Now, this is very simple. This is just if you understand what we mean by you see you know that I told you that this thing is the same as the circular motion. It could be related to circular motion. I mean, in fact, this is same with circular motion. So because it is the same as circular motion, the motion is more or less the same. We use a cycle to describe it. So what this is just saying is that a fraction of 360. You remember that 360 degrees is what? 2 pi, right? So we're just saying that we have a particular wavelength out of the actual wavelength, which is a circle, times 360. You understand? So it's more like what we're just making a fraction of 360 degrees. So that's where that formula is coming from, of 2 pi. You understand? Of 2 pi, a fraction of 2 pi, a particular wavelength. You want to know the length of a particular portion of the wave over the actual wavelength, over one wavelength times 360. So we want to know what it translates to in degrees. Do you understand? All right. So there are two ways of calculating it. There are two ways. And I'm going to show you the two ways. Now, in the first way, we have this. If I denoted this point A, this is our origin O, and I call this point B, C, A, B, C, D, F, G, H, I, J, K, L, M, and N. Now, I now ask you, find Jemima, find the phase difference between points B and D. 1, 2, point F and K. 3 points G and M. All right, let's find the phase difference between these three portions, these 3 points. The first one says B and D. So where is B? B is here. And where is D? D is here. So there are 2 ways to go about it. The first way is to check how much wavelength it has completed, and that's when this formula is very useful. So in the first, we say the phase difference will be 2 pi x over lambda. So what is our x? Is x we first find. So x is the distance between B and D. So the distance between B and D is what? Let's check. Now, if this is a wavelength, remember that we said this is a wavelength, right? So from here to here is a wavelength, is one wavelength. So it means that from here to this place will be what? Half of a wavelength, isn't it? So it means from here to here will be a quarter of a wavelength, isn't it? Good. And from here to here will now be what? If here to here is half of a wavelength, half lambda, here will be what? 1 over 4 lambda. What does that mean? It means from here to here will be what? 1 over half of this will be what? 1 over 8 lambda. Is that okay? So if this is 1 over 8 lambda, it means that from here to here, in fact, will also be what? 1 over 8 lambda. From here to here is 1 over 8 lambda. Then from here to here, also be another what? 1 over 8. So that is 1 over 8 plus 1 over 8 plus 1 over 8 plus 1 over 8 to give us half. What? 1 over 8 plus 1 over 8. 1 over 8 here plus another 1 over 8 plus another 1 over 8 plus the last 1 over 8 is equal to 1 plus 1 plus 1. 4 over 8. That is 1 over 2. Do you get it now? So here, this portion and this portion all together means that from here to here is what? 1 over 4 lambda. So our from B to D is, our x from B to D is what? 1 over 4 lambda. So what does that give us? We now say that our phase difference will go to what? 2 pi times x. What is x? X is 1 over 4 lambda. So 1 over 4 times lambda all over lambda. So what will happen? Lambda will take care of lambda. So with that, what are we left with? We have 2 pi phi equal to 2 pi times 1 over 4. So now if you are told to give your answer in degrees, you just say phi will be equal to 360 times 1 over 4. Near one here, 90. So phi will be equal to 90 grams. Do you understand? So that is how to go about it. Now, the second one, which says F and K. So from F, this is F, A, B, C, D, E, O. I skipped. So A, B, C, D, E. Anyways, this F and K. This is my F and this K. So from here to here, Jeremiah, are you done? So from here, from F to K, we want to calculate the phase difference. So what's the phase difference? Now, remember it is 2 pi x over lambda. So what is our x for this case? Remember, from here to here is what? Half of a wavelength, just like here. So here to here is half of a wavelength. And here, what? 1 over 8 of a wavelength. So what do? We add half plus what? Plus 1 over 8. So an half plus 1 over 8 should give, yes, half plus 1 over 8 should give us 1 over 2 times 1 over 8. That would give us 10 over 16, that would be 8. 2 in this 4 plus 1, that would give us 5 over 8. It is 10 over 16, okay. So 5 over 8 lambda, that's what we have there. So x is 5 over 8 lambda. So what do? We just say 2 pi x, which is 5 over 8 lambda, times 1 over lambda. From here. So lambda cancels lambda. So from here, if 2 pi was given as 360, we are asked to give an answer in degrees. This will be 5 over 8. 4 here, 8 here 1, in fact. 8 here, if 4 here is 90, 8 here will be 45. So 45 times 5, that gives us 5, 25, 2 to 5. 2 to 5 grams. And that makes sense. It's not up to a cycle. Look at it from here. You see, it's not up to a cycle, it's 2 to 5. So we are correct. You can envisage your answer. Now let's do the last one. Now for this last one, I'm going to use the same method, but I will now do another one where I will now show the second method using the same questions. So let's do G and M here. So what's the distance between G and M? Where is G? You have G here. And where is M? M is here. So looking at this, here, from here to here is 1 over 8. So 1 over 8 minus this from here to here should supposed to be half. So we don't. It means that 1 over 8 has been removed. So we have some portion left here, and here also 1 over 8 has been removed. We have some portion left here. So what does that mean? It means that 1 over 8 will give us 1 over 4, isn't it? A quarter. So it means that a quarter has been removed from a wavelength, isn't it? So that gives us 3 over 4 lambda. Our x will be 3 over 4 lambda for G and M. I don't know if you understand what I did. You know that from here to here is 1 over 8. And from here to here is 1 over 8. So we are calculating for this portion. So we have removed this portion and removed this portion. So what we have is that 1 over 4 has been removed. So what we have here is actually 3 over 4 wavelength. Because this 1 over 8 plus 1 over 8 has been removed, we have 1 over 4. So what do we have? We have that phi will be equal to 2 pi x over lambda. So 2 pi times x is now 3 over 4 lambda times 1 over lambda. Lambda takes care of lambda. 4 in 360, that will be 90. So 90 times 3, that gives us 270 granite, and that is the answer. All right. So, and that is it. Now let's now go to use the second method. Now the second method is very, very simple. What you want to do is this. Let me draw a smaller wave now and see what we have now. And see what we have rather. So if I have something like this, let me draw just one wavelength. As this guy is, the distance from here to here is, from here to here is 2 pi. If we were using trig, you know this is trig graph, the sine graph. Is that okay? So in this sine graph, sine theta, graph of from f of x is equal to sine theta. Sine theta at here we have 2 pi. At this point we have what? Half of pi, half of 2 pi, which is what? Pi. So it means that this point will correspond to what? Pi over 2, isn't it? So it means that half of that, what would that correspond to? Pi over 4, isn't it? It means that this portion will correspond to what? 3 over 4 pi, isn't it? This portion will have what? Pi plus half. Pi plus pi over 2. That will be 3 over 2 pi. You understand? All right. So using this trick, it means that we can calculate the distance between here. B and D was just here and here, right? So B and D, this is 3 over 4 pi. And this is pi over 4. It means that we can just say 3 over 4 pi minus pi over 4. So what does that give us? We have LCM is 4, 3 pi minus pi. What will this give us? This gives us 2 pi over 4. And that is what? 1 over 2 pi. So what is 1 over 2 pi? Remember that pi, since 2 pi is 360, 2 pi is 360. So what will pi be? Pi what? 180. So half of pi is what? 1 over 2 pi will be equal to 1 over 2 times 180, which is what? 90 degrees. So that was why we got the 90 degrees here. Do you understand? We did 1 over 2 pi. So 1 over 2 pi, pi is 180, so 1 over 2 times 180, and that is also 90. So that was how we got our 90 degrees here. Now, let me just solve one more, the second one, or let me solve this third one. So you using that same method, all you have to see is, since from here to here is pi, so you subtract here. What is here? You know that here, from here will be pi over 2, right? So let me draw that out here. So you have a graph like this, and you are giving rather than starting from here. Remember that here is pi. So, and here is supposed to be 2 pi. Is that okay? Well, this one has been subtracted, and this one has been subtracted. What does that give you? It means that what you are supposed to have 2 pi here, this small portion, what's this small portion? You know that this is pi over 2. So this small portion will be half of this one, which is what? Pi over 4. So pi over 4 has been subtracted in both places. So pi over 4 plus pi over 4 will give us what? 1 over 2 pi. So 1 over 2 pi has been subtracted. So if 1 over 2 pi has been subtracted, it means from 2 pi, we have subtracted from 2 pi, we have subtracted half pi, isn't it? This will give us, if we work the mass, that should give us 3 over 2 pi. So from here, it means that it's 3 over 2 pi that we're calculating with. So 3 over 2 times pi, which is what? 3 over 2 times 180. Here 1, here 90. 3 times this, it was what? 270 degrees, which was what we got here. So that is how to calculate phase difference. If you have not already, now I want to activate what I usually teach. So if you have not already subscribed to the channel, do well to subscribe to the channel and get us to 1 million subscribers. Is that okay? It's not too much. 1 million subscribers is not too much, right? And don't be surprised that I'm not starting small. I'm starting big. You understand? You must dream big. That's what I'm saying. So take us to 1 million subscribers, and God will bless you as you do so. So share this content with your friends who might need it. And I see God bless you. See you in the next video.